Hello everyone, and today I'm going to walk you through an exciting Gen AI project that I've built, a cold email generator. It uses a hosted LLM that is LLaMA 3 by Groq and Langchain, Streamlit, and ChromaDB as well. So the main project idea is like it extracts job postings from any career page, and from that it extracts key info like role, experience, and skills, and then uses an LLM to generate a personalized cold email. It is great for outreach, job applications, or even business development. Now let's walk through some main files of this project. The first one is main.py. This is the entry point and UI of our app. I'm using Streamlit to build a simple interface where the user pastes a job URL, and then when the submit button is clicked, it triggers the chain to extract jobs and generate a cold email using LLM. We also display output email directly on the page using st.markdown. This one. Now the second main file is change.py. This file contains the brain of our project, the logic that handles prompt creation and LLM calls. We define a chain class here with two main methods. The first method is extract jobs method. This one. This method creates a prompt that instructs the LLM to analyze job descriptions from a web page and return structured data like the job role, experience, required skills, and a brief description in valid JSON format. Here is a prompt we are going to pass, and this is the argument. This is the page data that we have extracted earlier. Then the write email, the second method. This is the JSON where the data is converted into JSON format. And yeah, this is the second function. This method generates a cold email. It uses another prompt that gives the LLM all the job details and a list of matching portfolio links, and asks it to write a concise and professional email. As if you are like Vineet Sharma, as I mentioned my name here, the business development executive at Atlic company. Both prompts are passed through Langchain, and the responses are passed using JSON output parser where needed. Now the third main file is portfolio.py. This file handles portfolio link matching using ChromaDB. We start by reading a .csv file with two columns, text tag, and links as well. So in the portfolio class, we embed each row using ChromaDB's vector database. Later, when we extract job descriptions, we run semantic search on them to get the most relevant portfolio projects based on matching skills. This is the main method here we have described. It is using ChromaDB, as you can see. Pandas is this basic library, and UID is used here in order to uh, mention the sequence number for the documents. Now the last file is requirements.txt. Here requirements file is not there. It's in my GitHub repository. Yes. Finally, this lists all the Python packages needed for the project, like Streamlit, LangChain, ChromaDB, and Python.nv. Anyone can recreate the environment by running the command I have mentioned in this README file, that is pip install requirement.txt. Now, one quick tip I would like to add here. Keep your API keys like the Groq key inside this .env file private, and don't upload it to GitHub and your other projects as well. Just use python.env to load it securely inside your script. As I can't show you this file because it contains my API key, which needs to be kept private. Now let's come to the demo. Let me quickly demo the app. We can run our web app with the help of this main.py file. After mentioning the whole path here and giving the command, it gives us the link to the. And this is our web app. Here we have posted this URL. This is the URL of the Apple job post page, and we are going to submit this. So as you can see, here is our output, and it is not giving just one email. It is giving several emails according to the number of job descriptions given in that post of Apple company. Here I have posted that URL of that post, job post page. And one most important thing, the response time is very, very low, as you can see, just because of the Groq Cloud. As I'm using Groq Cloud here, it uses something like LPU, language processing unit. Just because of that, the response is very, very fast. So guys, if you found this project helpful or inspiring, please give it a star on GitHub and feel free to try it. Thanks for watching.